So this is just a quick video of how we designed our car. So from the onset we decided that we were only going to have 3 wheels because number one, we didn't need 4, which would allow us to save a lot of weight. So we have 2 wheels at the back and 1 wheel at the front, and the 2 wheels at the back are driven by the motor, and we decided to drive the back wheels. We decided to drive 2 back wheels instead of having 2 wheels at the front driven or only 1 wheel at the back, because it gave us more traction by having 2 wheels driven, and also by having it at the back. When the car was accelerating, the center of mass would shift towards the back, so then we would have more friction between the wheels and the surface, so we'd get better traction by having the wheels at the back. We also decided to choose smaller wheels, so we were either going to go with the 56mm wheels or the 40mm wheels, depending on which gave us a better final drive ratio. And the reason for this is because of the higher moments of inertia associated with the heavier wheels, and we actually have a quick demo to show this.
So for this demonstration we have 2 bike wheels. They're very similar, and the biggest difference between them would be their mass. This is the lighter wheel. It has a mass of 1.6 kilograms. This is the heavier wheel. It has a mass of 1.9 kilograms. It's almost 20% heavier. I now have the wheel in the bike, and I have a weight attached to the pedal. This weight, when I raise it up, will pull down on the pedal and spin the wheel. This device here will give me the speed that the wheel is going from that sensor there. We're going to do 3 tests with both wheels. Drop it. Drop it. Go. That time we got a maximum speed of 10.4 kilometers an hour. This time we get a maximum speed of 10.6 kilometers an hour. This time we got a maximum speed of 10.6 kilometers an hour again. Now we have the lighter wheel installed. We're going to do the same 3 tests. Go. Go. So that time we got 11.6 kilometers an hour as our maximum speed. Go. This time we got 12.2. This time we got 11.5. The lighter wheel achieved a higher top speed in all 3 tests, showing that with the same force it's easier to accelerate a lighter wheel.
So that demo was just to show that it's very important to get the wheels as light as possible, because not only will it be easier to accelerate them in a linear direction, but also it'll have much easier circular acceleration because of the lower moment of inertia associated with lighter wheels. So that's why we chose the 56mm wheels, because they give us a slightly better final drive ratio over the 40mm wheels, and they weren't that much heavier. So we're now going to take a more detailed look at the chassis. So we always wanted to hold the bottle this way, so it's slotting into the chassis, because while we were also holding the bottle this way, we were also saving weight because we had to cut out this huge chunk of material. So that saved us a lot of weight. And we'll just have a closer look at it now. So this is just the front chassis. Holding the bottle this way made the chassis quite long, so we're actually at the 250mm limit of our piece of aluminium, so we had to split the chassis in 2. So this is just the front bit, and so these 4 holes here are how we attach it to the back part of the chassis, and then these 4 holes here, they hold the front wheels, or the bearing block for the front wheels, and this cutout here is what holds the single front wheel, because we're only using 1 front wheel because it's lighter. We decided to So we had to make a small modification to the bearing block in order to attach them. So we put threads into the bearing block like so. So these are M4 threads, and this provided us with a very easy way of attaching it to the front chassis. And also, if when we test the car, if it's veering slightly left or slightly right, we could file out a small bit of these holes up here and here, and then we can adjust the tracking of the vehicle ever so slightly so that we can get it running exactly straight. Also, we've decided to put in these vertical sections here, so we were just going to bend the inside of the aluminium up, because after cutting out the hole for the chassis, we were only left with this slim bit of aluminium to support the chassis, and what we discovered was that it would flex quite a lot while trying to support the bottle, because the bottle is quite heavy. So if we added in these vertical sections here, we would reduce the flex by quite a lot. And Dr. Tanner demonstrated this in a lecture with finite element analysis, and he showed that if you just add these small little vertical sections, you reduce the flex of the chassis substantially. So if we go towards the back of the car, we can see that the rear part of the chassis has to hold the motor and the battery box securely. So one of the conditions with the battery box was that it had to be removed from the it had to be able to be removed from the vehicle instantly, which ours is. There's nothing holding it at the top here. It's just held in by this flap here, that flap. This flap at the back, and the motor here just holds it in this side, and so that would keep it steady. And the rear section of the chassis also had to hold the motor in place in such a way that it would allow us to tension the belts. So if you see here, these two pulleys are in line, and we have these slots cut out here for the so that we can move the motor up and down, so that we can get just enough tension on the belt. So if we have a closer look at the rear chassis, this is it here on its own. So these are the slots for the motor, and this here is for the motor, for the protruding bit of the motor, so that we can have it flush against the aluminium. And this should actually be a slot as well to allow for vertical adjustment. These four holes here are what will these are where we can attach the bearing blocks. And these four holes here will line up with the back four holes on the front chassis. And again, we cut this bit of the chassis out here to save weight. We were thinking about cutting out a small bit down here to save more weight, but we decided against it because we felt that it would allow too much flex when the motor was exerting a force on the axle. So that's a basic insight into how we came up with this design, and just so that you have a better idea of how it all comes together, we can explode this and then collapse it. So this just shows how it'll come apart and then come together. And then we collapse it. So that's how the entire car will come together. Thanks for watching, hope you enjoyed the video.